Hello, my name is Joana Chora and I'm one of the biocurators of the FH VCEP. In this video is just an explanation on how I use the PP3 and BP4 in silico prediction codes. So here are our guidelines, our approved guidelines. And for PP3 and BP4, we first have a caveat to not use it if PVS1 is met. Then we also say that if both missense and splicing prediction are applicable, only one of them is needed to apply BP3. Only one of them is needed to predict pathogenicity to apply PP3. But both missense and splicing need to be indicative of benign for BP4 to be given. So we have for missense variants, we recommend the use of Revel, and this is pre-computed on the VCI. I'll show you a little bit later. And we have these thresholds. So values above 0.75 are supportive of pathogenicity, and values below 0.5 are supportive of benign. For the in silico prediction of splicing effects, we first also say that if we have functional studies on RNA, so splicing is looked at, we do not recommend doing in silico prediction in those cases. And then, but if you don't have functional data, we have three instances where we can use, and we recommend the use of max and scan. So here are the little schematic, but these are mostly, as I said, three situations. So either your variant is located near the canonical splice sites, either the acceptor splice site or the donor splice site, and then you will do what we say here to how to predict the impact of splicing for situation A. For situation B, the variant is creating a potentially new splice site. So it, creates an AG or it creates a GT inside the exon. And for situation C, our variant is located near an exonic cryptic site. So these are AGs or GTs that occur normally on our exon, and they could be, I'm going to say, activated by our variant and to be used preferentially instead of the canonical sites. So this is the impact that our variant can give. And then we have here exactly what kind of scores we want to test for each of these situations. So I have here an example. This is our variant. And for the in silico prediction, we looked at Revel. So I said Revel is pre-computed and you can see it in the VCI, you have it here. And the score for this variant is 0.30109. So this is obviously not above the threshold of 0.75, so we cannot apply PP3 just yet. But as we said, only one of them, either missense or splicing, needs to point to pathogenicity for PP3 to be given. This score is below the threshold for benign, so below 0.5. So you could potentially give BP4, but you need to check splicing first. So you need to check splicing for you to apply either one of these cases. We've noticed that we have no functional data, so we can go here and just check. We searched it and we saw that there are no functional studies in the literature. And so we can go ahead and try to see if our variant is in one of those three situations, A, B, or C. Personally, I created this file to help me, and I'm going to distribute this. This is a Excel sheet. Just this helps me a little bit because you can see here that for example, for case A, it's pretty straightforward. You can see, if you know exactly the limits of the exons, you can see the exonic nucleotides that are here on, that fall on case A, or case either acceptor or donor. But for B and C, it's a bit more tricky because it needs to be inside the exon, but it needs to be at least 50 base pairs away from the other splice site. So you can only have an acceptor splice site if you are at least 50 base pairs from the canonical donor splice site. This is what these thresholds mean. And for C, it's even more complicated. So I've made this file, and you just need to come here into this yellow cell and just input the number of your nucleotides. So our variant is 1171 G2A. Just put here 1171. You go first check here, see exactly in which exon our variant is. So it's 1171, falls within this, so it's on exon 8. And you just highlight this line because it's going to be useful. And if you want to check if this nucleotide falls within the limits of A, you can come here and see the highlighted line, and you see, does 1171 fall within here? No. Does it fall within this? No. So it's not on A limits. You can come here, you just say A not on limits. Then you go and see if it falls within B. Within B, you have this here. So if you want to go and check if it creates an AG, if it falls within these limits, or if it creates a GT, if it falls within these limits here. So 1171 is outside of these thresholds, so you don't need to check if it creates an AG, but it is within these limits. So you need to go and check if this variant creates a GT. And how do I do that? I like to use Mutalizer. Come here, you just input, so you can use either transcripts or the genome reference sequence, but I usually use genome reference sequence because it works either for exonic variants or intronic variants. So our variant is this here. I'm gonna copy, paste it here, and this actually is supposed to be doing is check if the name is correct, but it also gives you here a little bit of the gene where our variant is. So it is a G2A. So in this line here you have the wild type sequence, and then this slide here you have the variant, the sequence with the variant, and this is our variant. It's a G2A at this position. And so we can see this. What we wanted to see. We wanted to see if the variant creates a GT. So you can see here that the variant will be GAC. So there's no GT around here. So also B, it does not create a GT. So you can come here, go on B instead, does not create GT. And then we go and check C. To check C, you have this here, and you can first look at this first line, and you need to go and check if there's an AG from these, if these limits fall within these limits here. So if the variant is, as you can see here, the limits are 1061 to 1138, and this is not fall within here, so you do not need to go and check if there's an AG nearby your variant. But these limits here, 1165 to 1174, fall within here. So if it falls within here, you need to go and check if there's a GT nearby. Nearby here means exactly 6 nucleotides before and 3 nucleotides after your variant. And this aligns with our picture here. So our picture, this is our case. The case we want to check is this one, this last one. And this is where neutralizer comes in handy again. You need to go and check if there's a GT in these 3 nucleotides after the variant. You can see here that it doesn't. Or in the 6 nucleotides previous, the 1, 2, 3, 4, 5, 6. There's no GT here. So because there's no GT in either of these sides, you can see here, no nearby GT. So what does this mean? This means that this variant, it's not within the limits that we would assume that might influence splicing. So PP3 is not met because we found no evidence that this variant impacts splicing because it's not on the limits that we expected to impact splicing. So what does this mean for BP4? We can copy the same conclusions here, but this means that BP4 can be met because the variant does not lie within the limits that we would assume that would impact splicing. So we can assume that this variant does not impact splicing. So we can give BP4, this is met. And then save. And then I have another example. Another example here's for this variant, 185C2G. And we have here missense. So we can see the Revel score. That's 0.612. This is not above 0.75, so we need to check splicing. For BP4, we can already say that this does not meet BP4 because we need both missense and splicing to point to a benign variant, and this is not below the 0.5 threshold for Revel that we want. So BP4 is not met. We can say this right now. But for PP3, we need to go and check. So again, we have our variant, it's 185. We come here and see 185. This is within exon 2. It's within exon 2, but it's not on A because it's not on these limits and it's not on these limits. Do we need to check B? Well, we do not need to check if it creates an AG because it's not within these limits, but it is within these limits. So we need to check if it creates a GT. So we come here, copy our variant, we paste it here, we check. So we need to go and check if it creates a GT. And we can see here that it does not. It's a C to G, but it doesn't have a T nearby, so it does not create a GT. You can say here, so A, not on limits, B, does not create GT, and then we go and check C. Okay, to check C, 182 to 205 does not fall within these limits, so we do not need to go check if there's an AG nearby. But 179 to 188 falls within these limits here, so we need to go check if there's a GT nearby. So nearby, again, this means we are in the same. So we are in the same example. We are here. Our variant is near. We need to go check if there's a GT near our variant. And these limits are, so 6 nucleotides before, or sorry, 3 nucleotides after. So 6 nucleotides before, 1, 2, 3, 4, 5, 6. You can see there's no GT here, but in the 3 nucleotides after, you can see there's a GT right after it. So this has a GT here. So we are truly in this situation, and then we're going to need to compare these two scores. Okay, so the scores we need here, we need to see the cryptic site scores, so the scores for these GT with the variant up here, or with the wild type score without the variance. Okay, and then we need to compare this score here with the canonical site score. And these are the values that we go here. So for the splicing predictors, we do not have the predictions here, but we have the links for max and scan. And this here, our variant here is on this side here, so it's donor splice site. So the donor splice site, it's this one. It's exactly this one. Okay, so it's the 5' splice sites. So you have here an example of how they want the data to come. So you need to input 3 nucleotides from the exon and then 6 nucleotides from the intron. You don't need to capsize the letters, but just here for easy to see. What does it mean when we have a cryptic site? That means that we want GT and then 4 nucleotides after it, and then the 3 nucleotides before the GT. So where do we have the GT? We have it here. So we want 4 nucleotides after the GT. So GT 1, 2, 3, 4. We want it from here. 3, 4, GT, and then 1, 2, 3 before the GT. Does that make sense? So this is the variant. I'm going to put here, flag faster. So variant, cryptic site. And then you just paste it here. Okay, and then we go and copy the same for wild type. So 3 nucleotides before the GT, and then GT, and then 4 more. 1, 2, 3, and 4. Copy this. Put here that's wild type cryptic site. And then here. But we also want the score from the canonical site. So we can go, if you want, we have here the limits of the exons, and we already know that this is on exon 2, so you can go and see this one, because it's donor site. This limit here, you can input it here, or in the file that I sent here, I already have some pre-computed splice scores. So you want the donor splice site for exon 2. This one is here. I already have the value here, but I'm going to put this here for max and scan for you to check if it's the same. So this is the canonical donor site. Okay, and then you check the maximum entropy model to score and then put submit. So these are the scores. I'm just going to copy them to our VCI so I can write what I need. So I'm just going to use this here. So let's go and see here again. For C, we are in situation C. Okay, we want. So the variant is located at -3 to +6 bases relative to an intra-exonic GT denucleotide, which is at least 50 base pairs downstream of the authentic acceptor splice site. Okay, this is our case. We want results of both. So variant cryptic wild type cryptic score. We want it to be above 1.1. Just kind of copy all of this here so we know. And then also cryptic donor, authentic donor score. We want it to be above 0.9. Okay. So you might want to see here, right here is there is a GT nearby, and then mesh maximum max and scan scores are these. You can just copy. This one is this. The wild type cryptic site is this one, and the canonical donor site, it's this one. So I can delete this. And these are the two ratios that we want. So ratio variant cryptic above wild type cryptic. This is what we're going to substitute with the numbers we have here. So variant cryptic site is this, divided by wild type cryptic score. So wild type cryptic score, it's this one. And we just do the math here. So 2.64 divided by 5.58, and it's a negative score, so it's going to be a negative value. So minus 0.47. Okay. So this is not above 1.1 as we want it to. So we can say it is not above 1.1. Sorry. But we also want to check the other ratio, which is cryptic donor over authentic donor score. And the cryptic donor is the variant cryptic donor, sorry. Cryptic donor, actually, yeah, it should say here, variant cryptic donor over the authentic donor score. So I'm gonna here, variant cryptic score is this value here, divided by the canonical donor, 7.39, which is 0.39, 7.39, which is the one that I have here. So, sorry. So we do the math for this one, 2.64 divided by 7.39, and this is the value, 0.36. I'm gonna round it up, 0.36. You might want to use 3 decimal values if you want. I'm just gonna use it here because these values are obviously not near the thresholds that we need. So it is not above 0.9. So this, what does it say to me? Says that PP3 is not met, because even though the variant is near a cryptic site, it's not raised the score of that cryptic site enough to be used instead of the canonical site. This is what these numbers here mean. So PP3 is not met because we did not found here a reason to say that this variant impacts splicing. Okay, why don't we give BP4 point here? Because of Revel score, and we want to both missense and splicing predictions to be benign for us to give the BP4. Okay, so this is not met, and this is not met, and this is how it is. As I said, I'm gonna share this document. It needs to be in editable form for you to input values here, but I'm going to ask, please, everyone that uses this, do not change anything here except this yellow cell, please. Also, if you by any chance need to do one of these splice sites that it's not filled out here, you can fill it out for everyone else to use, please. If you have any questions, don't hesitate to ask us. Thank you.